Starting in 1. Hello, my name is Beth Dixon, and we are doing a review for Math 1830, Calculus A, and this is for Laura Moneyhun, and we're doing some review chapters, and we are doing section 0.2 in this video. The goal of this is to be able to use and interpret interval notation, and let's jump right in. So we have a number line and we have a graph on that number line, and I always go, me personally, I go from the graph to interval notation and from the graph to inequalities. I never go from inequalities to interval notation or from interval notation to the inequalities. I always use the graph to bridge those two. So if I have a graph, I can go straight to interval notation. If you watched video 1, I did give you some notes, and I'm going to repeat those notes here. And it's important that you have these concepts down. We have 2 types of interval, and those intervals are called open and closed. The open intervals involve the concept of less than and greater than. They also involve the use of parentheses, and they involve positive infinity and negative infinity, are all under open intervals. In an open interval, which we have here, and we can understand that because they use the open dot on the number line, an open interval means that as we approach the end of that interval, we never actually can end it. It's open. We can get to 1.1, and then we can get to 1.01, then 1.001, 1.00001, 4 zeros then a 1, 5 zeros then a 1, 6 zeros then a 1, but it remains open because there is never an end. For those of you old enough, MC Hammers, you can't touch this. You cannot touch the 1 because it's not part of your interval, so therefore it is open. You can't touch it, it stays open. The same thing with infinity. Infinity is out here. Positive infinity is always to the right. Negative infinity is always somewhere off to the left, and you can't touch those. They are impossible to touch. They are in the open side. In the closed intervals, we have your less than and equal to, your greater than or equal to. We use our brackets to show that they are closed, and when graphing on a number line, we make those a solid dot. If it had been a solid dot, we could have all those other values I mentioned, but eventually we could also say 1, and we've closed that door. We can't go any further. And so we have a place to stop. Therefore, it is a closed interval, and we have an end. If it has an end point, we call it closed, and it stops. And those are the 2 different. If you need to pause, make sure you've got these notes down. I'm going to erase those so I can finish working on this. So this one has an open interval. We already discussed that. That open interval starts at 1. In interval notation, we'll use either one of these and one of these, and it'll always be the small to the large. The smallest number to the largest number, with either the parentheses and then the parentheses to the bracket. Not both, but whichever it is. Is it a closed interval at that end or an open interval? So as I look at my example here, I guess I could have left that. We know that it's open here. We know that it's open down here. And we know we're starting our smallest number. And when you think about your smallest number, remember that that means it's moving from left to right. And so the smallest numbers are on your left, your largest numbers are on your right. So you're going to read this from left to right, which is really convenient because we read in the English language. And in the English language, we read from left to right. So we're going to start from the left, which is 1. The largest number, well, it keeps going, so that means it's going to be positive infinity. And then we're going to use open intervals on both sides. Infinity always gets the open interval. So in interval notation, it's 1 comma infinity. Let's look at the second example, which should go a lot quicker because we have our base notes. It's a closed interval here because it's got the dot. So we know it's closed. That means our small number was going to start with a bracket. The small number to the most left is a 1. And then the number to the most right keeps going. So that's going to be positive infinity. And with a positive infinity, we don't need a sign. And infinity always gets a parentheses. Notice that we can mix and match brackets and parentheses together in the same set. So now let's look at these examples, and this will help show you how I always use the graph. Again, I go from interval notation to the number line, and then from the number line to inequality. In reverse, I go from inequality to the number line, and then from the number line to interval notation. And if I'm given the number line, I go from number line to interval notation, and the number line to inequality. I never go from the interval notation. I never go from here to here. No! Do not skip here. Now I'm going to erase that because that's not really necessary to do the problems. But as I go through those, you'll notice I never skip the picture. A picture is worth 1,000 words. Okay, so let's start. In the first problem, we have the interval notation given. We have bracket 3, comma, infinity. So that means we're going to start at 3. It has a bracket, so that means it is a solid dot. How do I know that? How do I know that? I know that because on that first page of notes, a bracket goes with the dot. Then that's the small number. The large number goes to positive infinity. Remember, I'm just going to kind of write that at the top. Positive infinity is to the right. Negative infinity is over here to the left. So that's going to shade in that direction. So I've got the number line. Once I have the number line, I can then write my interval notation, I mean my inequality. Well, these, I can start with my x, and then my 3, and these are x's are, it's the x's where I shaded, are those are my x's is where I shaded. Are they greater than 3 or are they less than 3? Well, they're shaded to the right, and the right makes the numbers larger, so x's are greater than or equal to, again, because we're in a closed, and we have a closed dot that should have an equal to. Next, we have the graph first, so let's do the interval notation first. It's from left to right. The most left point is just keep going and going, so that would be negative infinity. Infinities always get parentheses. The rightmost point is 0. It's an open circle, so it also gets parentheses. When I come over to write my inequality, Again, I'm not going to look over here at the interval notation. If you have a way of doing it that does that, that's great. I'm showing you how I do it. I tend to write my X, and then the number that sits around is 0, and then I see that it shades to the left. It points to the left, so my little symbol's going to point to the left. It's open, so I do not need an equal sign. Okay, the third one down, they're not really numbered, but the third one down gives us the inequality, which is X is greater than or equal to 1. So that means it's equal to, it's going to be closed, so I need to close my dot at 1. I'm going to close my dot at 1. X is greater than that, so that would mean it would shade to the right. Numbers are larger than 1 to the right, so I'm going to shade to the right. And then that gives me my shading. Then looking at the number line, the smallest most number to the left is 1. It keeps going to positive infinity. I don't really need a plus, so I'll leave that out. The 1 is a dot, so it gets a bracket. Infinities always get parentheses. Next on the list, I have 2 numbers, and the X is between. So anytime you have the X between, that really means what it looks like. X is between a -2 and a -1. Now, the -2 doesn't have an equal to, so that means the -2 gets an open circle, and the 1 gets a closed circle. And if X is between those two, you shade between. So you might want to make yourself a note that if it's between, this just means that you're going to shade between. And we've done it. That makes the interval notation really easy because that means you're going from -2 to 1. And the -2 is open, so it gets the parentheses. The 1 is closed, so it gets the bracket. Lastly, we're going to look at the graph on the last one. Again, we're going to read from left to right. It looks like it stops at -4, but it's got an arrow, so that means it keeps going and going. So we're going to look at that negative infinity as its end point, because it just keeps going and going, which means we're headed to negative infinity. That means it's headed down here to this, and to the negative infinity. And so then it stops at -1 on the other side. Which would be -1. The negative infinity always gets the parentheses. The -1 gets a bracket because it is a closed interval. Closed intervals get brackets. Closed intervals also get an equal to. So when I come over here, my inequality will get an equal to. So that's going to be X. And then I'm going to have a -1. And these values with -1 are smaller than -1. They are to the left of -1. So it will be less than or equal to -1. Now, a couple of things that I want to mention right here as you look at this. If the X comes first, the direction the inequality points is the direction you graph. Less than shades to the left, it points to the left. The greater than points to the right, it's shaded to the right. The less than pointed to the left, it's shaded to the left. And another thing that you can, that kind of helps me, remember when I put the notes up about closed and open? To me, it takes more to write a bracket and less, well, let's do here. It takes more to write the bracket than it does to write the parentheses. It takes more to write the dot than it takes to write the circle. So that's how I keep straight that the bracket goes with the dots and the circle goes with the parentheses, and that it takes more to write the equal to, and it takes less to write the less than. Here we've got a less than or equal to. Less to write here, less to write here, less to write here. More to write here, more to write here, more to write here. It's a stretch, but that's how I keep it in groups. And you want to group those as two separate. Make sure that you have those down. And that concludes the video for section 0.2. You're moving right along. Oops. I do need, about forgot, no, that doesn't conclude. The practice from your textbook, I do need to conclude that. Here's your practice from your textbook. It's on page 14, problems 29 through 34.